Hi, I'm Miss Hall, and this is Lesson 85, Compound and Disjoint Events. Compound events. When you consider all the outcomes for either of two events, A and B, you form the union of A and B as shown in the first diagram. A union B. That is the symbol for union. When you consider only the outcomes shared by both A and B, you form the intersection of A and B as shown in the second diagram. A intersection of A and B. The union or intersection of two events is called a compound event. To find the probability of A or B, you must consider what outcomes, if any, are in the intersection of A and B. Two events are overlapping when they have one or more outcomes in common, as shown in the first two diagrams. Right, so these first two diagrams are overlapping. And two events are disjoint or mutually exclusive when they have no outcomes in common, as shown in the third diagram. Disjoint, mutually exclusive is this third event. Big idea here, the core concept is the probability of compound events. If A and B are any two events, then the probability of A or B is probability of A or B equals probability of A plus probability of B minus their intersection, probability of A and B. If A and B are disjoint events, then the probability of A or B is the probability of A or B equals probability of A plus probability of B. I still have the orange. Okay, so this third diagram is an example of when you would use disjoint probability. You would add up the probability of A plus the probability of B, and there's nothing to subtract because there's nothing in their overlap. And then diagrams 1 and 2 are examples when you would use the first formula. You add up each independent probability and then subtract the intersection. Example 1, finding the probability of disjoint events. A card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a 10 or a face card? So one way to approach this problem is to draw a Venn diagram of the two events. And that is a 10 or a face card. So there are 4 10s in the deck. Right? There's the 10 of hearts, the 10 of clubs, the 10 of spades, and the 10 of diamonds. And then for face cards, there is a jack, a queen, a king of hearts, a jack, a queen, a king of spades, a jack, a king, a queen, a king of diamonds, and a jack, a queen, a king. I think I'm missing clubs. You see there is nothing at that intersection of these two events. So these are disjoint events. They have no overlap. Therefore, we can use the second probability formula. The probability of A or B is equal to the probability of A plus the probability of B. And I'm going to call the 10 event A, face card event B. So the probability of selecting a 10, there are 4 in a deck of 52 cards, plus a face card, there are 3 times 4, that is 12 out of 52. And this is really 16 out of 52 when I add those fractions. And this can reduce to 4 out of 13. So the probability of A or B is 4 out of 13, which is approximately 0.308, which is 30.8%. Example 2, finding the probability of overlapping events. A card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a face card or a spade? I'll set up my Venn diagram. My two events are face card or spade. Okay, so the overlap of face card and spade are the three face cards that are spades. So the jack of spades, the queen of spades, and the king of spades. And then the other sets of face cards are not spades: jack, queen, king of hearts, jack, queen, king of diamonds, jack, queen, king of clubs, I think is what I missed. So we're trying to find the probability of A or B, and we have overlapping events because there's information at the intersection. This is going to be the probability of A plus the probability of B minus the probability of A and B. So probability, let me label this one A and B. Probability of a face card, well, there are 12 out of 52 face cards, plus probability of a spade. Oops, there's more than just the jack, queen, king of spades. There is the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Makes sense. 13 out of 52 are spades. Then we need to subtract the intersection, which is 3 out of 52. This is 25 minus 3, which is 22 out of 52. Okay, so the probability of A or B is 11 out of 26, which is about 0.423 or 42.3%.